In this segment, I will talk about using Cuisenaire rods to discuss the ideas around division. So, we did the multiplication family or facts of the number 6 in our last segment, we're going to be using those multiplication facts to help us with our division. When we're talking about multiplication, we're talking about groups of equal size pieces. So if we're talking about division, we have to talk about how many sets or groups of equal size pieces. So if we have the question 6 divided by 2, we could read it as 6 divided into groups of 2. So how many groups of 2 are in 6? So our colors that are associated with our 6 is our dark green, and our color associated with our 2 is our red. So another way of asking this question is how many reds are there in 6? So how many reds are in a dark green? And so we can see that we have 1, 2, 3 reds. And so my answer to this question would be 3. Equal size pieces, which are reds or R2, how many of them are in R6? So in this one we knew how large our groups were. Our groups were of size 2, and we were looking at how many groups we have. And our answer would be 3 groups. The other way we could look at a division question is you say, I know I have 2 groups. How big would the pieces have to be? So what shape could I do 2 of to make my 6? And I would use my light green here on that one, and I know that 2 light greens will make a dark green, and therefore my answer is a light green, which is a 3. So again, either way I get the answer of 3. When we're talking about division or multiplication, we can think of 2 groups of size 3 in multiplication, or groups of size 2, and we have 3 of them. In division, there's 2 ways of looking at it. And we can think of it as, I want to divide it into groups of size 2, how many would I have? And I could also think of it as, if I want to divide it into 2 groups, how big would each group be? Using a similar kind of example, I have a rod that's size 8, or which is a brown, and we want to find out how many reds are in that. And we can see that there's 4 reds in a brown, and therefore if I want to have them into groups of size 2 or size red, I would have the answer of 4. The other way of looking at this question, if I have 8 and I want to divide it into 2 groups, how big would the pieces have to be? So if I wanted to get it into 2 groups, if I take a yellow, 2 yellows would be too big, and so I know 2 yellows can't be my right answer. It has to be something smaller than that, so I go to 2 purples, and 2 purples would give my answer to me. And my purple is worth a 4, and so therefore 8 divided by 2 is 4. So here is size of 2, how many would I have? 4. Here is, I have 2 groups, what would their size be? If multiplication is repeated addition, then division is repeated subtraction. So another way of looking at this question, if we want, is if we say 8 divided by 2, is how many 2's are in 8, or how many times can I take 2 away from my 8 and get down to 0? I could take 2 away once, I could take 2 away twice, I could take 2 away 3 times, and I could take 2 away 4 times, and that would give me my answer. So how many times can I subtract something is another way of looking at it, but the things I have to subtract have to be equal size groups. The other way of looking at it for this question is, if I want to subtract something twice, what would the size have to be? So if I wanted to subtract something 2 times, I can't use my reds because there's too many reds to make up a brown. I would have to subtract something bigger. I'd subtract a 4 once, and I'd subtract a 4 again. What size pieces would I have to do it if I did it 2 times? My answer would be 4. So there's 2 ways of doing it. The first one is when we're talking about how many times can I subtract a 2, and that's how many times can I do it? What size would they be? If this one, the second one, was saying if I do it 2 times, what size would they have to be? So there's the 2 ways of looking at it. How many groups of 2 can I take away? And I know the group size, and this one would be if I take something away 2 times, what is the group size? Working with remainders is somewhat confusing for students. So if I take 3 divided by 2, my question is, how many times can I take a 2 away from the 3? Or how many groups of 2 can I have? My 2 is a red, so I can take one group out, but I don't have enough for 2 groups. So what do we call this piece right in here that I have? One piece is not enough, but 2 is too much. So what do we call this piece right in here? What do we do with that? Well, if I take my red here, and I'm just going to line it up here, and I do something like this, I know that a red and a white is going to make my green. So how many 2's can go in there? 1, 2, and a white. Well, what do we call a white? Well, we could give my answer written this way. I could take my 3 and I divide it by 2 and I get my answer of 1, and there's my 1 right there, with a remainder of 1. And I know my white is a 1, so I can call that remainder 1. And in the earlier grades we could leave it like that. If we wanted to do a question like how many yellows are in a black, we know that there's 1 and there's 2 pieces left over. So I could say I could take 7 divided by 5, 7 divided by 5, and that's going to equal 1 yellow, and I'm going to have 2 1's left over with a remainder 2. And we can leave it like that until we get to a little higher grade. When we get to the higher grade, we want to do something with these remainders. So in this example here, I could say this 1 is what part of a 2. Remember, we're asking how many times can I take 2's out? How many whole reds can I take out? Well, I can take 1 whole red out, and I can take out a half of 1 red. So this 1 is 1, but I'm dividing by 2's. So 1 divided by 2. So I can give my answer of 1 and 1/2 is also an acceptable way of writing my remainder. On this question down here, if I have how many times can I divide 7 by 5, how many yellows can I have in a red? I have 1 yellow and I have 2 whites left over. Well, what part of a yellow is 2 whites? Well, I know a yellow is made up of 5 whites, and since I only have 2 of these right here, I could say therefore that 2 is 2 out of 5 pieces, or 2/5. So now I have a visual to represent what my remainders mean. And so this is a nice introduction to division. Once they understand what division means, how many groups or how many sets of numbers can I take out of a number, how many go into a number, how many groups can it make to make up a number, then it's a nice way of looking at what do I do with my remainder. So in this segment we've talked about division. We've talked about division as saying how many of a certain size we have, how many size 2's can I have in a block of size 3. I could also say if I wanted to cut it into 2 pieces, how big would the piece have to be? And in this example, we could look at it and say if I cut my green into 2 pieces, I have enough to make 1 1/2 in each of my 2 pieces. So I can divide it into 2 pieces. How big would each piece have to be? Or I can say if I'm dividing into size 2 pieces, how many would I have? I'd have one red and half of a red. So either way I would get 1 1/2. So I've talked about how to do division and think of it in 2 different ways: size of the piece and the number of piece. I've also talked about what it would look like when we have remainders. We could have it as a remainder 1 or a remainder 2, and we've talked about how we can redescribe that remainder. Instead of just a remainder 1, it's 1 of my size 2 pieces, or 1/2. 2 out of my size 5 pieces, or 2/5. So I've talked about my remainder as a fraction piece as well.